Okay, so now we're going to go over how we perform a significance test for a population mean. So just like with significance tests for population proportions, we got to check conditions. So the same ones as we used when we constructed confidence intervals for a mean. So we got the random condition, make sure the data is coming from a well-designed random sample or randomized experiment. 10%, make sure that you take no more than 10% of the population, and a normal large sample. This is the key distinction where you want to make sure that either the problem says that the population has a normal distribution, or if it's not saying that, then check that you have a sample size of at least 30. Now, if neither of these are met, then you got to graph the sample data and inspect it. And you basically want to be able to say that it's reasonable to think that the population could be normal. And we say that when you don't really have any strong or extreme skewness and no outliers. Okay, then, just like with significance tests for population proportions, you're going to get a test statistic with the same form, statistic minus a parameter over the standard deviation of the statistic. So if your null hypothesis would be that the true mean is, something, we're going to use mu sub 0 or mu ho or, or whatever mu not, whatever you want to call it. Then we're going to have a sample, where we get a sample mean, x bar. That'll be our statistic. So x bar go here, mu 0 will be here. And then the standard deviation of the statistic, what we would like is, the true, standard deviation. So if you remember from chapter 7, the standard deviation of the sampling distribution of x bar. Now, ideally, if we could get the true population standard deviation, we would have just a z-score or, our z statistic. But the problem is that, if you're collecting data, you're trying to figure out what the true population mean is. So you're probably not going to have the true population standard deviation because you're going to need the true population mean, and you're going to need a lot of data. And it really doesn't make sense for you to have this value because you're probably going to know then what the true population mean is, and then you wouldn't do a study because you don't need to do a study because you already know the answer. So, you wouldn't have this. You wouldn't have the true standard deviation. So then, just like before, we use the sample standard deviation to estimate the true standard deviation. And so we have the standard error in the denominator. So we can't use a z-score because that wouldn't technically be accurate. We're going to use a test statistic of t. So just like with what we did with confidence intervals. So with t distributions, they're unique. So that means that they have a slightly different, shape depending on the sample size. So we have to consider the degrees of freedom. So degrees of freedom will be one less in the sample size. So again, very similar to population proportions, and those are very similar to, the confidence intervals. So overall, we're going to have three possibilities. We're going to be looking at the probability of getting sample data that's going to be greater or, to the right of that test statistic, or to the left, or, less than, or not equal to when you consider both sides. So to the right of the absolute value of t, and to the left of the negative absolute value of t. Now, of course, the best way to get good at this stuff is to go through practice problems. So that's what I'm going to do. I'm going to go through it and explain step by step how we conduct this and how all that applies. So here we're going to look at an example. We got two students that like to Abby and Raquel, they like to eat sub sandwiches. And they noticed that the lengths of the advertised 6-inch sub sandwiches that they usually get seem shorter than what they advertise. So they decided to investigate, and they selected 24 times at random, 24 times at random over the next month, and they ordered the 6-inch subs. And here's their data of the 24 sandwiches they got. So the question is this data convincing enough at the alpha equals 0.1 significance level that the sandwiches at this restaurant are shorter than advertised on average? And after we come up with the conclusion, we're going to then talk about what type of mistake we could have made, a type 1 or type 2 error. And then what are the possible, like ramifications that could result from that type 1 or type 2 error. So as usual, we're going to use our 4-step process, state, plan, do, conclude to answer this question. So our statement would be that our true mean, our null hypothesis, says that our true mean mu is 6. And the alternative is that the true mean mu is less than 6. And again, make sure you define what mu means in the context of the problems, and make sure you identify the significance level. In this case, our significance level is 0.1. So our plan is to use the one sample t-test for mu as long as the conditions are met. So the conditions that we just went over are the random condition. So it says that the times are randomly selected. So then we could say then, okay, then the subs were randomly selected. So that condition's met. 10%, that we take no more than 10% of the population. So that means that there were at least 10 times 24 or 240 subs that this restaurant makes per month. And that's very reasonable to claim. That's less than 10 a day. And then a normal large sample. Now, our sample size is only 24, and it doesn't say that the population is normally distributed. So we have to inspect the sample data because 24 is less than 30. So then we're going to enter the data in our graphing calculator. I got it in my list 5. And then from here, we go stat plot and make a box plot for the data. In my case, it's list 5. Zoom stat. And there we go. I like to trace it, hit trace, so then you can see the exact 5 numbers on the box plot. So then we draw a sketch. And you can see there's no outliers and there's no extreme skewness on this. So then it's safe to continue. So just draw a sketch, at least. And again, I usually advise box plots. I think they're the best, but you can use dot plots or whatever. Now, the do part, we just do our calculation based on our, formula or equation for t. And since our data is in our calculator, we can use it to run the one variable statistics. Oops, not that. And then here we got our sample mean of 5.68 about. Sample standard deviation, so use S sub x of about 0.66 and a bunch of other stuff. So we plug those into our calculator and we're going to get a test statistic of about -2.38. Now, since our alternative hypothesis is that the true mean is less than 6, we're going to be looking at the probability value or the p-value to the left of our test statistic. So sketch here. Hypothetically, we want to go to negative infinity all the way to the left. So the left bound or lower bound is like negative infinity or negative a billion, whatever. our upper bound, or the right boundary, is negative 0.38. So we want to see what this area is in a t-distribution with 23 degrees of freedom. Remember, one less than the sample size, 24 minus 1, 23 degrees of freedom. And I like to use technology. So you can go to distribution in your calculator, and right below, the normal CDFs that we were using, we have TCDF and TPDF. So we're going to use TCDF, and the syntax in this calculator is the left bound. So I'm going to enter like negative a billion or something. The right bound will be negative 2.38. And then in degrees of freedom, 23. And you can see that we get a p-value of about 0.013, or about 1.3%. And if you have a more like advanced or newer version of these calculators, it's probably easier. It's going to be easier for you to enter the values because you don't have to memorize the syntax, because it'll just say like lower bound, upper bound, degrees of freedom. Okay, and so since our p-value is less than our alpha level of 0.1, we're going to reject the null hypothesis. So we have convincing evidence that the true main length of their so-called 6-inch subs is actually less than 6 inches. Okay, so now in part B, we were asked, like, if we come to this conclusion, what type of error could we have made? And then what are the possible, results? Like, what could possibly happen that's, that we don't want to happen from making that mistake? So let's talk about the context, because again, that's what they're usually going to be testing you for, is to make sure that you can't, it's not to test you can do calculations and all that. That's the math, from algebra 1 or algebra 2. They want to test if you understand the concepts of statistics. So remember, a type 1 is when you reject HO when HO is true, and a type 2 is when you fail to reject HO when the alternative is true. So since we rejected HO, that means that we could have made a type 1 error. In other words, it's possible that HO is true, which means that their actual true main length was 6 inches. So that means that we could falsely accuse them, of lying and of cheating us, when in fact they weren't cheating us. And of course, we don't want to be talking bad, or it could potentially hurt their their customer and their revenue, because people may start thinking that this company is shady, and they start not going there because they're cheating people out of their out of their food. So always consider the possible consequences of making a type 1 or type 2 errors, because that's usually what's going to affect what your alpha level would be in real life. In significance tests, where you're dealing with like medical procedures like surgery and stuff, you want to have a very, 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 very low alpha level, because you don't want to, the chances of you making the possible ramifications of making a type 1 error or type 2 error could be very costly, or they're just extreme because you're talking about human lives. So keep that in mind, because we're going to be talking about that more at the end of this lesson. All right, so I hope that helps. Good luck.